Okay, so this what they're doing is they're taking this. That looks horrible. So this would be x0, and then this would be x1, x2, and then x3. We are approximating this with these rectangles, and then another rectangle here, then another rectangle here. I think it's the height is f of the later one. So what's happening here? Okay, so the ith, so xi is equal to, so the space between them is delta x, and then oh yeah, this is a and b are the starting position, right? So this is b, this is a. So x0 plus it with delta x, which is b minus a over n. So this plus the interval gives x1, and then plus 2 intervals gives x2, and then plus 3 intervals gives x3. So how many? This is I. So this is I times this means how many intervals we are going ahead. Okay, so for the area, right, this is how the area is being calculated. So the area under the graph is approximately f xi, right, then times that by the, so this height, let's say x3, this height times it by the interval. This would be the same throughout the sum. So this is the same throughout all the sums. And 2, 3. So how many intervals there are? How many intervals there are? Starting with 1. So it starts with this one, and then get the area of this. So this is the right endpoint approximation. Left endpoint. Okay. So right endpoint. Hold on. So right endpoint, we take this height. To get the area of the first part, we take the height of x1 multiplied by the interval. And left endpoint, we take the left endpoint as the height of the rectangle. So this is the area using the right endpoint, and then area using the left endpoint would be n, but this time it's starting with 0. So 1, 2, 3, 3 intervals, and then f of x I, where I is 0, times it by the interval. Over here they're doing I minus 1, but I think it will be the same f at 0. No, wait. It's n. 1, 2, 3. with this would also include the height of the rectangle right after. So it's actually n minus 1. So I and think this is what the book did. Is there a midpoint also? I think that would also make sense. Sketch the right and left. X, I, star is somewhere between the previous xi and the current one. So x0 star would be here, x1 star would be somewhere here, x2 star would be somewhere here. And this is called a Riemann sum. So the area under the curve y is equal to f of x on AB is given by limit n to infinity. Okay.